So the first speaker is Stefan Bruhn. He's an expert in media codec technologies in Ericsson, and he'll speak about EVS advances in VoLTE networks. Stefan.
Thanks a lot, Alex. So I missed actually to provide my bio data, so I should maybe tell a bit more who I am and what I'm working. I'm working for Ericsson. As Alex said, I have been working there for speech coding since back in AMR standardization times, AMR wideband standardization, wideband plus, and then obviously we also got the EVS codec. I am chairing the EVS sub-working group in SR4. Have done this since the beginning when we started this work in 2007 actually. So this was actually quite a long path. And my talk will be, of course, giving some background on the EVS from some kind of evolution perspective, how the speech service has evolved, and then I will give you some more insights into the this new EVS codec standard. Now let's see how it. No. Now, so let's start from really evolution perspective. Of course, we need to start from a traditional narrowband voice service, which everybody, well, actually I heard yesterday someone saying that narrowband service has existed since the 17th century. I don't know if this is true, but I don't think so, but at least it feels like this. And it's still out there. But of course, we have seen a lot of changes. We have seen the standardization of the AMR wideband codec, which originally was intended to be standardized as part of the AMR narrowband speech codec already. So this was 1998, essentially, when, or 97, when it was intended to be standardized. Then it was realized that the task was a little bit too big, and then it was shifted somewhat. So we got it standardized then in around 2001. It took quite a long while to get this service really being deployed. Now we see a lot of deployments. So the latest data from GSA is that we have really 116 commercial HD voice networks in 75 countries. Maybe by today it's even more. We have a lot of growth in this area. We have essentially all new phones are HD voice capable. And actually, of course, we have also seen in the field that there are many over-the-top players setting really the expectation of customers to high quality. This triggered really in 3GPP a discussion how we should also evolve the HD voice service. And this has then led to the enhanced voice service work item, and then finally in the standardization of the codec. And of course, why are we doing this? Apparently there's a business with HD voice. We are usually referring to Orange results who were really pioneering in this area. They have reported increased usage of a voice, really increased customer satisfaction, which is very important, which is maybe not always visible in the perspective that there is more money to make per minute, especially with flat rates on voice. But what is quite clear is that it will at least indirectly increase the revenue since either you can still use it for direct charging, or you would at least indirectly reduce the churn. Well, now, of course, coming to this traditional picture, what is narrowband, wideband, super wideband, and full band? We have seen this also already from HP. What is really important is to understand a little bit how these different spectral ranges influence not only the quality, but make really the voice more natural, what is really required if we want to have high music quality. And this is essentially the insight which was necessary to define really the standardization goal of the EVS codec. What we then, of course, achieved with the EVS codec, and this is really giving you already an overview picture of what this is. We essentially can use the EVS codec starting from AMR wideband, the HD voice codec, in different dimensions. We can either essentially keep the quality and increase the voice capacity. So this means that we can get the same quality, or actually even better quality, by reducing the bit rate. We can increase the quality while keeping, well, this is essentially this picture, by essentially keeping the capacity constant. And we can, of course, also go to much higher quality and, well, even spending more bit rates when available. And to give you some kind of impression how this is possible, I have prepared some sound files. Of course, there are a lot of files. I would just like to give you a short demo on increased quality at the same capacity, starting from narrowband, AMR voice to HD voice, and then going to EVS, starting with.
We show them our plan of how we, together with the city, can increase the profitability for all of us.
How did the meeting go? Were they interested in working with us?
So this was narrowband voice.
We show them our plan of how we, together with the city, can increase the profitability for all of us.
How did the meeting go? Were they interested in working with us?
And then finally, if I see, here we are.
We show them our plan of how we, together with the city, can increase the profitability for all of us.
How did the meeting go? Were they interested in working with us?
So what we see quite clearly is that the speech gets much more natural, much more crispy, and all at the same bandwidth of only 13.2 kilobit per second. And of course, we can also do the same for music. A similar example, also quite impressive, starting again with AMR narrowband. Wideband. And EVS. So what we perceive are much more spectral details coming with the high frequencies, but also reduced distortions. Because, and I will explain this a little bit more, this has to do with the new architecture of the EVS codec. So as a kind of summary of this first part of the talk, so what does really what do we get from this, from HD voice and the evolution with the EVS codec? It's for the consumer benefits, of course, having increased voice quality, then this excellent music quality, what we just perceived. And of course, what becomes more and more important is applications like stereo or what HB displayed for conferencing applications, that we would really be able to play back some kind of conferencing scenario in multi-channel. On the operator side, of course, what is very important is to have some globally interoperable service based on 3GPP standards. So this is something different than having just some over-the-top service, which is not really telco grade. Then, of course, it is definitely also the improved network capacity, so and the same, improved quality at the same bandwidth usage. And what is also quite important here on this picture to see, in LTE systems, we will have the packet switch operation, so there we have the EVS codec. Then we have the existing 2G, 3G networks with the AMR wideband, the HD voice codec. And here we have the seamless interoperation between the EVS codec and the existing AMR wideband codec. So this means that from user perspective, it will not be a difference really whether you are in a 2G, 3G network or LTE network. Of course, in LTE network, you get the even enhanced service, but essentially you can roam around in this space and always get enhanced voice service, while of course in 2G, 3G, it is falling back to HD voice, which is existing today. Now some insights, and I think I have to be quite brief here, some insights into the EVS codec features and some other details into the EVS codec. What we see here is bandwidth operation from narrowband to full band at a large range of bit rates, starting from 5.9 kilobit per second VBR to 128 kilobit per second if we are in full band, for example. We have some smart bandwidth control, meaning that for a given bit rate and depending on the input signal, we will always be ensured that we get the optimum quality. So it will select essentially the coding bandwidth. Features, traditional features like VAD, DTX, confound noise generation are of course a must for efficient operation. Then we have some new things, a channel-aware mode, which is important for impaired channels to make the service really robust. Then other parts which are usually not included are included. We have a packet loss concealment part of the standard, jitter buffer management part of the standard. Then, well, rate adaptation support is of course also very important. We can switch at frame boundaries of 20 milliseconds seamlessly without really any artifacts, and some audio resampling conversion, audio rate conversion, making it possible really to decouple the bandwidth operation of the codec from the actual input and output audio sampling rate. To the technology, what we have is essentially a hybrid of traditional LP-based coding, which is model-based coding used for speech coding traditionally, and frequency domain coding, so that we can switch in a smart way depending on the input signal, whether it is speech or music. On the LP-based coding, we have some kind of traditional ACAP, linear predictive coding, and we have some high band parameterization, so bandwidth extension for the MDCT coding mode or the frequency domain. We have MDCT coding, also in some well, limited bandwidth, and we use some high band parameterization for bands that do not need to be coded directly. Coming to 3GPP standardization, we have spent a lot of efforts to standardize this codec. What is important here is really that 3GPP has really applied some open, transparent, fair, and constructive way. So essentially, and this is also looking back into the history, how we started standardizing this codec. We were many players who were, of course, competing against each other. Still, in the 3GPP standardization framework, we managed to come together to standardize together this new EVS codec. This is quite some achievement. And of course, the working principles which we applied is really that we work based on defined work item objectives, upfront definition of terms of reference, an open process to every 3GPP member. Everybody was able to participate in this exercise. Well-defined standardization phases, starting from qualification over selection and characterization, including verification. And of course, also very important, all decisions that were taken in 3GPP were unanimously agreed in 3GPP SF4. So everybody was on board with the standardization. And also quite impressive to mention here is the testing campaign. So we have spent a budget for testing of more than 1 million euros. We performed 70 subjective performance tests in independent test labs. At the same time, there were also certain objective criteria that needed to be met, so that it was not, for example, not possible just to optimize quality of a system operating with discontinuous transmission, but we needed also to fulfill the constraint that the channel activity should not exceed a certain threshold. Okay, and coming to the results of this selection testing, we see that we have only 0.5% systematic failures of requirements, and even this can be explained by just statistical coincidence. So essentially, it is fair to say that the codec has met all the requirements. And even looking at the objectives, which are even higher targets, we have a codec that has met 13, which has not met 13% of the objectives. Okay, to the performance, this is of course also just some kind of it contains a lot of data. What is important here to see is how the blue codec, the EVS codec, performs over the green bars in different scenarios in narrowband, wideband, super wideband clean speech. We see that in many cases, even at low bit rates, we get transparent quality identical to direct. We have very strong results for wideband and super wideband music, and we have also strong results for super wideband, not only super wideband, but in general, performance of the codec in frame loss conditions. Coming next, just an overview. This looks quite busy. What is the EVS standard? Important here is that the standard is ready in the major parts. So the fixed point code of the codec is available. It can be downloaded from 3GPP, and implementations can really be made, can be started. There will also be a floating point specification, floating point code, that one will be finalized in December. And also worth to mention is that the work is continuing. There's actually also now a work item that targets standardization of the EVS codec for circuit switched. On the licensing, which is of course also very important, this is not a codec that is claimed to be royalty-free. It is a codec that really applies fair and reasonable and front licensing terms. Of course, this codec has a value and it applies the 3GPP licensing terms, which we think will be, of course, make really the codec easy to be adopted. Coming now to a summary, we have seen that 3GPP has selected the new EVS codec as standard for enhanced voice services in release 12. And this will enable the EVS enhanced voice service for MTSI, so especially VoLTE. And well, the standard is available now. You can download it, you can try it out. The EVS codec provides really unprecedented sound experience for speech and music and increased network efficiency for operators. And it provides a nice evolution path from HD voice with full interoperability to AMA wideband. And what is also quite important here is the mobile industry. There are 12 major infrastructure chipset device and technology vendors and operators, all these listed here that are behind the standard and fully committed to it. We wait for deployments, of course, in 3GPP, but we expect also deployments in fixed access, internet, and web RTC. And also to mention here that Ericsson is offering to host an interop testing event in 2015 for the EVS codec. Finally, before I really start, of course, one obvious question is, how does this compare to Opus? Of course, some might have the question. We performed actually some tests, and this is done, these are test results by Nokia in the bitrate ranges that are really important for efficient mobile operation, so up to 24 kilobit per second. We have it for clean speech, noisy speech, and mixed music, and we see actually quite a quality difference between EVS codec, which is the blue line, and the Opus codec. And I could also even play some examples to give you some impression, starting maybe for speech at the lower end at actually this is 7.2 kilobits per second.
We show them our plan of how we, together with the city, can increase the profitability for all of us.
How did the meeting go? Were they interested in working with us?
And the EVS codec then at the same rate?
We show them our plan of how we, together with the city, can increase the profitability for all of us.
How did the meeting go? Were they interested in working with us?
And we can also play the same example for music. And the EVS codec at 7.2. And I think, well, I have 1 minute, so I could still play maybe some more sounds. I can increase the bitrate to 13.2, starting again with Opus. and then EVS at 13.2. And thank you. I think this is then the end of my talk. Thanks for your attention.
Wonderful presentation. Thank you. Quick question: did I recognize the voice of Thomas Wigand in the clean speech or not?
I don't think so.
You don't think so? Okay.
No.
It sounded eerily familiar. So okay, good. All right. We can take a few questions. Okay.
What about complexity in terms of CPU consumption?
Well, we have defined complexity requirements for the exercise. The limit was about 2.5 times the AMA wideband complexity, and we are within this limit.
Oliver?
How does it compare? How does it compare against AAC for music content?
Well, actually, this is something we have not investigated. I think this would be an interesting topic to do in some kind of characterization. As I said, characterization is currently being executed, but there may be more phases of characterization that might even consider such cases. But we have currently we don't know.
Other questions? No? Okay, thank you so much. Thank you.
Thank you.